Prudent Scholars in association with Goa Headmasters Association.
Welcome back students for the session 2 of Polynomials chapter. In session 1 we covered how to find value of polynomial. We also learned how to find zeros of the polynomial in 3 different ways, like when 3 terms are given or when 2 terms are given, that is first and second or first and last. Also we learned little about the relationship between the zeros of the polynomial, that is alpha and beta, and the coefficients of the polynomial, that is a, b and c. We learned in that about 2 formulas, that is sum of 0 is equal to minus b upon a and product of 0 is equal to c upon a. So these things we had covered in the last session. Now let's proceed further. In today's session I'll start with to find the zeros, okay, using those 3 methods which we had learned, either splitting the middle term or finding the common factor or shifting the term. It depends what polynomial is given to us. And then the very important part is how to verify the relationship. Verification is important here. This problem mostly comes for 2 marks. So it's given here, find 0 of quadratic polynomial x square plus 7x plus 2l and verify relationship between zeros coefficients. Okay. See, now here the polynomial is given and what we are supposed to do is find its zeros. So what do? We always equate it to 0 first, whichever polynomial is given. Okay. Then what do? Is that polynomial we equate to 0. So I substituted that polynomial x square plus 7x plus 2l is equal to 0. Now if we recall what we have learned last time, whenever 3 terms are there, what do? We use splitting the middle term. That method we use. So I have here a, that is 1, c is 2l, 1 multiplied by 2l is 2l. So let's find the factors of 2l which will satisfy 7x. So we have many factors of 2l like 1 multiplied by 2l or 2 multiplied by 6 is equal to 2l and 3 multiplied by 4 is equal to 12. But out of these 3 pairs, the pair which will satisfy 7x will be 3 and 4, because positive 3 and positive 4 will give me positive 7. So I have here x square plus 3x plus 4x plus 2l is equal to 0. I used 3 and 4 which are the factors of 2l to get 7x. Both are positive. Now as usual we are supposed to group them. Now in the first group x is common, so take x out. So what remains is x plus 3 in the bracket. Then 4 and 2l, here 4 is common, so take 4 out, again x plus 3 in the bracket. These 2 brackets are same, so take it out. So what remains is x plus 4 and x plus 3. Again product of 2 factor is equal to 0, therefore either first factor is 0 or the second factor is 0. So if the first factor is 0, I am getting x is equal to negative 4, because positive 4 will change to negative 4 and this positive 3 will become negative 3. So I have 2 zeros here, negative 4 and negative 3. And as I had told you that I will denote 2 zeros as alpha and beta. So let my alpha be minus 4 and beta be minus 3. So this part we had learned last time. So 1/2 of the problem is done, that is finding the zeros. Now the most important part is verification, that is verify the relationship. Let's see how to verify now. So this was my polynomial x square plus 7x plus 2l. I kept this just for the reference purpose. Okay. Now have a look at the first step. The sum of zeros, alpha plus beta. So I am adding both those values which I got in the previous slide. I got my alpha is minus 4 and my beta is minus 3. So if I add minus 4 and minus 3, I get minus 7. So I got this by direct calculation. If I apply the formula, what is the formula? Minus coefficient of x upon coefficient of x square. This is related to sum now. Okay. So, if I apply formula, what do I get? Minus coefficient of x. What is the coefficient of x here? 7. So, I wrote 7 here. Minus is again the part of the formula. Coefficient of x square. Coefficient of x square is 1. So, I wrote minus 7 upon 1 is equal to minus 7. I repeat once again. To verify, we need to do first manual calculation, that is sum of 0 alpha plus beta. Okay. Alpha I got -4, beta I got -3. So, total becomes -4 plus -3, which is -7. Okay. Then apply formula. What was the formula for sum of 0? That is minus b upon a, that is minus coefficient of x upon coefficient of x square. So, you get minus 7 because minus sign of the formula, coefficient of x is 7. So, -7 upon 1 is equal to -7. Now, if you observe here, either you do manual calculation or you apply the formula, the answer is same. In both the cases, answer is same. That is why I concluded here. Therefore, sum of zeros, this sum of zeros is equal to this formula minus coefficient of x upon coefficient of x square. That is what? Because we are getting both the answers correct, that is left hand side and right hand side is same. This was for sum of zeros. Then we are supposed to verify for product of zeros. Now, how do I verify? Also, the product of 0, that is alpha multiplied by beta. So, minus 4 multiplied by minus 3. 4 into 3 is 12. Minus into minus is positive side. So, what do I get is 12. So, I get product as 12 if I directly multiply the zeros. Okay. Now, suppose I apply the formula. What is the formula for product of 0? It is C upon A, and C means constant and A is what? Coefficient of x square. So, if you see in this equation, constant is the last term 12. So, I place it over here. Coefficient of x square here is 1. So, 12 upon 1 is 12. Again, what happens? See, both answers are same. Therefore, I conclude that product of 0 is equal to constant upon coefficient of x square. So, this is the method to verify the problem. I will show you another problem with different signs. Previous problem, all terms were positive. Now, let us have a look with one term as negative. Find the zeros of the quadratic polynomial x square minus 5x plus 6 and verify the relationship. So, again we are supposed to find zeros. Now, again in this problem there are 3 terms. So, we are again supposed to use splitting the middle term method. So, zeros are given by f of x is equal to 0 and the polynomial which is given is x square minus 5x. Now, let us see here 6. 6 have factors like 6 into 1 and 2 into 3, and from those factors we require -5. All these things were done in the lower classes. Okay. So, -5. So, how do I get -5 from the factors of 6? I have 2 3s are 6 and -3 and -2 together can give me -5. So, I splitted this -5 as -3x minus -2x. Again, since I have 4 terms, let us group them. In the first group, I have x out common. So, what remains is x minus 3. Here, between minus 2 and plus 6, minus 2 is taken out. So, I have x minus 3 again is equal to 0. So, what happens here? X minus 3 is a common bracket, take it out. What will remain is x minus 2 in the second bracket. So, again product of 2 factors is 0. So, either first factor is 0 or the second factor is 0. So, if I compare, I get x minus 2 is equal to 0 or x minus 3 is equal to 0, which gives me x as 2 and x as 3, because negative sign will become positive. Here also the -3 will become +3. So, what do I conclude from this? I have 2 zeros here with me, that is alpha and beta as 2 and 3. So, again the first part of the problem is done. The second part is verify the relationship. So, this is my reference polynomial which was given in the question, x square minus 5x plus 6. Looking at this, let us verify. So, sum of 0, I had alpha as 2 in the previous sum and beta as 3. So, sum of 0, that is alpha plus beta, is 2 plus 3, which is equal to 5. So, I get 5 as my answer. Let us check using formula. So, what is minus coefficient of x upon coefficient of x square? This is a formula for sum of zeros, that is minus b upon a. So, this minus sign I have written here. What is coefficient of x? Coefficient of x is negative 5. So, I have substituted here in the bracket negative 5. Then comes coefficient of x square. What is coefficient of x square here? It is 1. So, negative into negative, positive 5. So, I get again both answers same. That means sum of 0 is verified. That is, sum of 0 is equal to negative coefficient of x upon coefficient of x square. So, sum of 0 is done. Now, the next part is product of 0. Let us first calculate product of 0. Product of 0 is what? Alpha multiplied by beta. So, alpha is 2, beta is 3. So, 2 multiplied by 3 is 6. So, this is we have done via calculation method. Now, let us go to the formula. What is the formula? Formula for product of 0 is C upon A, that is constant upon coefficient of x square. So, constant in the equation is 6. So, I wrote here 6 and the coefficient of x square is 1. So, I wrote here 1, 6 upon 1 is 6. Again both these answers are matching. So, again the final statement says that product of 0 is equal to constant upon coefficient of x square. So, in the previous two problems we have seen verification for 3 terms, quadratic polynomial which having 3 terms. But now in this problem I have a quadratic polynomial having only 2 terms, that is first and the last one. So, let us verify this. This I have taught you in the previous session how to find zeros when the first and last term is given. So, zeros are given by f of x is equal to 0. You can even mention p here, any alphabet you can choose, no harm. So, I have my polynomial as x square minus 7 is equal to 0. Since x square minus 7 is 0, I can shift this 7 to the other side. I will get x square is equal to 7. So, what is my x? X will be, square will change to root. So, it becomes plus or minus root 7. Therefore, I have two answers, alpha is equal to root 7 and beta is equal to negative root 7. So, these are my two zeros here. Okay. So, alpha is root 7, beta is negative root 7. So, again the first part of the problem is done. Let us move to verification. So, this is my polynomial x square minus 7. So, sum of zeros was alpha and beta. So, we are finding a alpha plus beta. So, root 7 plus negative root 7. So, they will cancel each other and the final answer will be 0. So, sum of 0 you are getting as 0. Let us see whether we are getting same using the formula. Formula is minus coefficient of x upon coefficient of x square. So, minus sign I wrote over here. Now, coefficient of x, there is no x in this polynomial. That means coefficient of x is 0. Second term is not there, only first and last is there. That means in this place of b I have to put 0 and 0 upon any number is always 0. So, again I get both the answers same. So, I can conclude this statement, sum of 0 is equal to minus coefficient of x upon coefficient of x square. Also, I have to find the product. So, the product of the 0 is alpha into beta. So, root 7 into negative root 7. So, positive into negative will give me negative sign. Root 7 into root 7 is 7. So, I have here negative 7 as my answer for the product. Let us see using formula. What is the formula for product? It is constant upon coefficient of x square, that is c upon a. Now, c is the last term constant which is negative 7. So, I wrote it over here and coefficient of x square is 1. So, negative 7 upon 1 is negative 7. Again both answers are matching, hence it is verified. Therefore, product of 0 is equal to constant upon coefficient of x square. So, in verification part I have done 3 sums, one using 3 terms, second one was again 3 terms with one term as negative, and in this one I have used only 2 terms, first and last one. Let us move on to next subtopic, to find quadratic polynomial. Now, here in this we are supposed to frame the quadratic polynomial. All this while the quadratic polynomial was given and we were either finding their zeros or we were finding their sum or product or we were verifying. But in this everything will be in the reverse form, that is zeros will be given, we have to frame quadratic polynomial, or sum and product will be given, again we will have to frame the quadratic polynomial. So, let us have a look at this subtopic. It is given here, if alpha and beta are the zeros of quadratic polynomial f of x, then the polynomial f of x is given by, means what, alpha and beta is already given, 2 zeros are already given. How to frame the quadratic polynomial? It is x square minus sum of zeros into x plus product of zeros. This is the format to find a quadratic polynomial. So, sum of 0 is alpha plus beta, there is a negative sign here and the variable, plus product of zeros is alpha multiplied by beta. So, this type of problems appear in the question paper where they ask you to frame quadratic polynomial in terms of particular variable. Now, if x is mentioned, please write the answer in x, use variable x. If they ask you to find the quadratic polynomial in terms of y, please write all these variables as y. It will be like y square minus alpha plus beta y plus alpha into beta. So, focus upon which variable is given, and if nothing is mentioned, it is your choice which alphabet to mention. But if any particular alphabet is mentioned, please see that you write that alphabet itself. Let us have a question here. Find the quadratic polynomial, the sum and the product of whose zeros are minus 2 and 5 respectively. Now, your sum is given as minus 2, that is alpha plus beta is already given as minus 2, and product is given as 5, that is alpha multiplied by beta is given as 5. And if you see in this question, they have nowhere mentioned any particular variable. So, it is your choice which variable to choose while framing the quadratic polynomial. So, it is given here sum as alpha plus beta negative 2 and product of 0 as alpha multiplied by beta, that is 5. So, we know that it is always one of the polynomial, because we can frame n number of quadratic polynomial using this sum and 0. So, one of the polynomial is f of x is equal to x square minus alpha plus beta x plus alpha into beta. This is a formula which I have just written here again. Now, what we will do is we will just substitute this part. Alpha plus beta is given to us negative 2 and alpha into beta is given to us as 5. So, after substitution it looks like this. So, there is negative 2 inside the bracket and this is 5. So, after solving, what do I get? X square. This negative and negative becomes positive 2x plus 5. So, this is one of the polynomial, because there are n number of polynomials which I can frame using this, which I will be showing you in the next few problems. So, this is x square plus 2x plus 5 is the required polynomial. Therefore, one of the quadratic polynomial is x square plus 2x plus 5. Okay, there is one more method by which you can solve this, that is comparison. Without, if you forget this formula, you can compare the coefficients and frame the equation. So, sum of 0 is always minus b upon a, and what was given in the question? Sum of 0 is negative 2. So, negative 2 can always be written as negative 2 upon 1. Also, product of 0 formula is c upon a, and it was given to us that product of 0 is 5, which can be written as 5 upon 1. Now, just focus on this part, this and over here. You have to compare, first compare a is same in both the cases. So I choose A as 1. Then compare B. Negative B is negative 2. So if I cancel negative sign, I get B is equal to 2. And if I compare C, C is 5. So now I have A, I have B, I have C. What is the standard form of quadratic polynomial? It is ax square plus bx plus c. So how do I write next step? Therefore, one of the quadratic polynomial is A is 1, so x square, plus B is 2, so 2x, plus C is 5, so it's 5 here. Now, very important part is that never ever equate this polynomial with 0. Okay, we are just framing the quadratic polynomial, so just write x square plus 2x plus 5. Don't write x square plus 2x plus 5 equal to 0, that is wrong. Okay, so you have to write x square plus 2x plus 5. So let's have a look at another type of problem. Find the quadratic polynomial, the sum and the product of whose zeros are 3 upon 8 and 5 upon 8 respectively. Now in this case sum and product is given, but now it is given in the form of fraction or in the form of real numbers. Okay. So it's given here sum of 0 as alpha plus beta 3 upon 8. It is already given, alpha plus beta is given as 3 upon 8, and product of 0, that is alpha multiplied by beta, is given as 5 upon 8. Therefore, one of the polynomial is, okay, I am just writing the formula here, that is f of x is equal to x square minus alpha plus beta x plus alpha into beta. What am I supposed to do now is that just substitute this value, alpha plus beta is given here, that is 3 upon 8 will come, and alpha into beta is also given, 5 upon 8 will come in the last place. So here I have x square, minus sign is already here, alpha plus beta is 3 upon 8, so I have substituted alpha plus beta is 3 upon 8 into x, plus alpha into beta is given as 5 upon 8. So I have put here 5 upon 8. Now this polynomial is in the form of fraction. So let us standardize this. What to do is that you have to just try to remove this 8, and to get rid of this 8, what am I supposed to do is multiply the entire equation by 8. Okay. So if I multiply this entire equation by 8, what do I get? 8 multiplied by first term, I get 8x square. If I multiply 8 with the second term, for that 8 and this denominator 8 will get cancelled. So I am left with negative 3x, plus if I multiply 8 here, 8 and 8 will again get cancelled. What will remain is 5. So I have the polynomial 8x square minus 3x plus 5 in more standardized form. Therefore, one of the quadratic polynomial is 8x square minus 3x plus 5. Okay. So it's mentioned here one of the polynomial because see, even this answer is acceptable, but since it is in the fraction form, I have written in the standardized form. Okay. So this is one type where the zeros, sum of the zeros and the product of the zeros are given in the fraction form. There is one more method in solving this same problem which I had shown in the earlier sum also, that is by comparing. Okay. So sum of 0 formula is minus b upon a, and which is given to us as 3 upon 8, and product of 0 is c upon a, and again this value is given to as 5 upon 8. So let us compare a first. Now a is 8 here, also a is 8 over here. So my a is 8, value of a is 8. What about b? Now just see, negative b is 3. So what will be b? B will be negative 3. Okay. So negative b is 3. So b is negative 3. So my b value is negative 3. And last, if you compare c, the c is 5. So in order to compare this, always first start comparing from a. A should be same, rest all you can compare. So I have a is equal to 8, b is equal to minus 3, and c is equal to 5. Therefore, one of the quadratic polynomial is 8x square minus 3x plus 5. So both answers are same, the previous one and this one. So whichever method you apply, the answer will be same. Either you can go by formula, that is x square minus alpha plus beta x plus alpha into beta, or you can use comparison method. But see that again I am telling, don't write this quadratic equation equal to, quadratic polynomial equal to 0. So let us focus on this problem now. Find the quadratic polynomial whose zeros are 3 and minus 2. If you see students, in the previous problem it was given here sum and product of zeros. Sum was given as well as product was given. But in this problem sum and product is not given, here directly zeros are given, and the two zeros are given here are 3 and minus 2. So if this type of problem appears, then how to get the quadratic polynomial? Since given here alpha as 3 and beta is minus 2, these are the zeros of the polynomial. So first let us find sum of zeros. Sum of zeros means you are supposed to find alpha plus beta first. So it is 3 plus negative 2. So your answer is 1, okay. And the product of 0 is alpha into beta, that is 3 multiplied by negative 2, you will get negative 6. So this part was given earlier in the problem, but now in this problem we are supposed to find this first. And as usual I told you the formula how to find the quadratic polynomial. The formula is, one of the polynomial be f of x is equal to x square minus alpha plus beta x plus alpha into beta. Now we just now found out these two values, alpha plus beta as 1 and alpha into beta as negative 6. So substitute these two values here. What do I get is alpha plus beta is 1 and alpha into beta is negative 6. So just reframe it again. So x square minus x and positive into negative is negative 6. Therefore, one of the polynomial is x square minus x minus 6. So this is what we get here, okay. This is just one of the polynomial, okay. Now let us focus upon the next problem. In this problem again find the quadratic polynomial whose zeros are root 7 and negative root 7. Here also zeros are given, not sum of 0 is given, neither product of 0 is given. So it is just given here zeros. So we have alpha as root 7 and beta as negative root 7. So first, in order to find the quadratic polynomial, we are supposed to first denote this as alpha, this as beta, and then find what is alpha plus beta and alpha multiplied by beta. So as here is given, alpha is root 7, beta as negative root 7. Therefore, sum of 0 is equal to alpha plus beta is equal to root 7 plus negative root 7. Now here this is positive root 7 and this is negative root 7. So whenever you have positive and negative together, when you add them, it will get cancelled and your final answer will be 0, okay. Now product of 0 is alpha multiplied by beta. Now what is alpha? Alpha is root 7, that is your first 0. Beta is negative root 7, that is your second 0. Now if you multiply this dot represents your multiplication, root 7 into root 7, okay. So root 7 into root 7 will give you 7 and positive into negative will give you negative. That is how you get product as negative 7. So what do you have? You have sum as 0 and product as negative 7. Now what we are supposed to do is, let us frame the quadratic polynomial. Therefore, one of the polynomial is f of x is equal to x square minus alpha plus beta x plus alpha into beta. This is my general formula. Now substitute x square minus alpha plus beta. What is alpha plus beta? We found it as 0. So in this bracket you substitute 0, x plus alpha multiplied by beta. Alpha multiplied by beta we found as -7. So, in this place you put -7. So, this term will vanish because 0 multiplied by any variable will give you 0 again. So, you are left with the first term x square minus the last term, that is x square minus 7. Therefore, one of the quadratic polynomial is x square minus 7. So, this is quadratic polynomial we found out only having two terms, that is first and last. Second term is missing. It is not there just because sum of the zeros is 0. Okay. Now, let us have a look at one more type of the problem, little applicative type. Write a quadratic polynomial in y. So, it is specifically mentioned here the polynomial should be in terms of y variable. So, do not get confused and write there x. Please read the question carefully. With a is equal to 2. So, they have mentioned that the polynomial should be with the coefficient of x square as 2. Sum of 0 is 7. It is given as sum of 0 as 7 and product of 0 as 6. So, this time sum and product is given. So, let us start our problem by using these two information, like sum is 7 and product is 6. So, what is given? Given is sum of 0, and we know that sum of 0 is negative b upon a. This is given as 7. So, it is already given that sum of 0 is 7. Also, it is given product of 0, which is c upon a, as 6. So, even c upon a is given. So, if we compare this, this 7 means denominator is 1 and here 6 means also denominator is 1. So, if you compare, I will get a as 1 because it is upon 1, here also upon 1. In both the places a is same. So, a is 1, b, negative b is 7. So, what will be b? B will be negative 7. Okay? So, b I got as negative 7 and c will be 6. So, I have a, I have b, I have c. A is 1, b is negative 7, c is 6. Therefore, the quadratic polynomial is, if I use this ABC, my quadratic polynomial will be y square because a is 1 minus 7y because b is negative 7 and plus 6. Okay? But the main question says that a should be 2. So, what we should do here? A should be 2. So, I have to multiply this entire polynomial, quadratic polynomial by 2 so that the first term, that is a, becomes 2. So, next step, it is given here but a is 2, hence the required quadratic polynomial is, I have just multiplied this just to satisfy this condition, that is a is equal to 2. So, 2y square minus second is 7. So, 2 into negative 7 is negative 14 and 2 into 6 is 12. So, this satisfies the condition with a is equal to 2. That is why I always mention it is one of the polynomial. So, even this is accepted, but since the condition is mentioned, the final answer will look like this, 2y square minus 14y plus 12. So, thus I summarize what we have learnt in this lesson. Okay? The first point which we have learnt is, if p of x is a polynomial and alpha is any real number, then the value obtained by replacing x by alpha in p of x is called value of p of x at x equal to alpha, and it is denoted by p of alpha. So, I had given earlier a few examples. Suppose you have p of x is equal to x plus 3, and suppose I give you value of x as 1, then p of 1 will be 1 plus 3. How did I get 1 plus 3? I just substituted x with alpha, and in this case alpha is 1. So, p of 1 will be 1 plus 3 is equal to 4. That is how we get value of polynomial. Next point to focus is upon the real number alpha is 0 of polynomial if p of alpha is 0. So, we in the first session we learned about how to find p of alpha, that one polynomial is given and one alpha is given, and then we are supposed to find the value. But one condition I stressed upon is that if alpha, after substituting alpha, the final answer turns out to be 0, then what do we call that alpha as? Then that alpha will be called as 0 of the polynomial or root of the polynomial, or it can be also called as factor of the polynomial. So, p of alpha is 0 implies that alpha is the 0 of polynomial. So, this we have learned. Third point to be focused upon is that to find zeros of the polynomial of the type ax square plus bx plus c, ax square plus bx and ax square plus c. All these three types we had done. In the first part, all the three terms are given. So, we had used splitting the middle term method here. We used to use multiply a into c, then that value you split in such a way that you get b. So, we use splitting the middle term to find zeros. Okay. Then we focused upon the second type where first and second term is given. So, when first and second term is given, what you are supposed to do is you are supposed to take out the common. Don't make a habit of changing this to the other side. It will give you wrong answers. Okay. Don't change bx to the other side or take it to the right hand side. You have to find common and then compare your values to 0. Okay. And the last part what we had done is ax square plus c, that is first and last term is given. In this, if you shift c to the other side and then solve, it is allowed. You will get 2 roots. Mind you students, since it is a quadratic polynomial, in all the cases, the answers should be always, you should get always 2 answers, either 2 roots, 2 factors or 2 zeros. Okay. So, in all these 3 cases, you are supposed to get 2 answers. Okay. Then the point of discussion was verification. Once you find sum of 0, product of 0, we found about, we learned about verification. Okay. Also, we learned about how to derive this minus b upon a and c upon a. So, if alpha and beta are 2 zeros of quadratic polynomial ax square plus bx plus c, then how did we find sum of 0? Sum of 0 was alpha plus beta, that these are our 2 roots. Sum of 0 is minus coefficient of x upon coefficient of x square, and coefficient of x is b, so it is minus b. Coefficient of x square is a, so it is a over here, and the final answer is minus b upon a. This is sum of 0. Product of 0. Product of 0 is alpha multiplied by beta. Okay? And for this the formula is constant upon coefficient of x square. What is constant? Constant is c and coefficient of x square is a. So, we have c upon a. So, students, this part is very important. It can be asked in objective questions or it can even be asked for 2 marks question. Okay? Different questions can be framed using these 2 formulas. So, sum of 0 is minus b upon a and product of 0 is c upon a. And remember this part also because this is utilized while verifying. Okay? When the problem comes for verification, you need to know this, that minus coefficient of x upon coefficient of x square, and for product constant upon coefficient of x square. And the last point which I taught you in this session is that if alpha and beta are the zeros of quadratic polynomial f of x, then the polynomial is, how do we derive? F of x is equal to x square minus sum of zeros into x plus product of zeros, and sum of zeros is alpha plus beta and product of 0 is alpha into beta. Once again I would like to tell you, never ever equate this with 0 because we are just finding the polynomial here, quadratic polynomial. Okay? So, that is it.